Introduction to logarithmic functions. Here we talk about logarithmic functions, which is written as log with something called a base, a, and with some number, b. Now, what does this mean? Well, instead of explaining what this is, you can actually just learn logarithms by saying that it's something that cancels with the exponential functions just like these. So, like 2 to the third power is equal to 8, right? And then log of 2 of 8 is log of 2, and 8 is 2 to the third power, so that's equal to 3. Okay, so even without me telling you what log of a of b is, you already figured out that log of 2 of 8 is 3 just by knowing these two cancellation laws. These two cancellation laws in fact define what a log is. Now, it is equivalent to saying that the logarithmic function is the inverse function of the exponential function. That's somewhat more abstract approach to defining it, but to evaluate this logarithmic function, you only need to know these two rules, and that's enough. So let me give you some examples, and hopefully by then you'll be convinced that these two are really enough to define what log of a of b is. So let's see. How about log of 3 of 81? Okay, to make use of the cancellation law, you have to turn 81 into 3 to some power. 3 to what power is 81? Well, 81 is 3 times 3 times 3 times 3, right? Because 3 times 3 is 9, 9 times 9 is 81. So how many 3's did you multiply? 4 times, which means log of 3 cancels with this 3, so that's equal to 4. Another one, log 4 of 16. Well, that's easy. 16 is 4 times 4, so it's 4 squared. So that gives you 2. Now here's another one, which is a little bit more challenging than the one before. Log of 5 of square root of 5. What would that be? Well, you have to remember that square root in terms of exponents is the same as 1/2 power. And then these two cancel, which gives you 1/2. Okay, still more examples. You're probably getting more comfortable with logs by now because you've seen how to evaluate it. But to be more comfortable, you need to know more examples. After seeing lots of examples, you probably figure out what logs mean. Okay. How about log of 5 of 1 over 5? Well, the reciprocal is same as -1 power. So that means these two cancel and gives you -1. So log 5 of 1 over 5 is -1. How about log 5 of 1 over square root of 5? That's like combining the two previous examples together. First you say reciprocal is -1 power, but then square root is same as 1/2 power, and then log of 5 of 5, -1 times 1/2, that's -1/2. And finally you can say this is equal to -1/2. Alright, that was a little tough, but we managed to do it. Okay. Now you might still be complaining you still don't know what log is, and but you're still able to figure out the value of what a log is. Okay, it's like meeting a new person in the party, and you only know his name, that's all you know, but then later on you start talking to him, you get to know more about this person. Just take that approach, and at some point you'll be very comfortable with what log is. Alright, again, still another one. Here is an example log 2 square root of 2. What is that? Well, that's log 2 of 2 to the first power times 2 to the 1/2 power. And you know that when you have two exponential expressions with the same base, then the exponents add up, right? So it's log 2 of 1 plus 1/2, which is log 2 of 2 to the 3 over 2, and these two cancel, and therefore you get 3 over 2. That's what log 2 of 2 radical 2 is. Alright, so that's like the most basic introduction to what log is. To summarize, log is something that cancels with the exponential functions, and you can evaluate it by using those cancellation laws. I'm not claiming that you would understand what log is fully at this point. In the next video, I will show you some basic rules of the logarithmic functions, and at the end of the video, I'll be able to explain to you the logarithmic functions again as the inverse function of a given function. So until then, this is all I have. Please watch the next video.